Have you ever stopped to think about how we first learned to make sense of the world? It all starts with the basics, right? The absolute fundamentals. Well, today, we're going to go on a little journey back to the very beginning. We're going to rediscover something we all think we know, 2D shapes. And by looking at how these ideas are first taught, you might just see the world around you in a whole new light. So let's kick things off with a question you probably haven't thought about in years.
Okay, what is the difference between a square and a rectangle? It sounds so simple, doesn't it? It's something you learned as a little kid. But when you really try to pin down the exact definition, well, it can be surprisingly tricky. And that's exactly the kind of foundational idea we're going to dig into today.
So before we can even get to the whole square versus rectangle thing, we've got to go back even further. We need to agree on the ground rules. So first question, what even is a 2D shape? At its heart, it's this simple. A 2D shape is just a flat shape, something you can draw on a piece of paper. The 2D just means two-dimensional. It has length and it has width, but that's it. No depth. There's a real kind of elegance in how simple that is, And that one definition is the launch pad for everything else.
And here they are, our main cast of characters for today. You know them, you love them. The circle, triangle, square, rectangle, pentagon, and hexagon. We're about to take these familiar shapes and figure out what really makes them tick. All right, so we've got our shapes. How do we tell them apart? Well, the very first tool we're given, our first clue in this little geometric detective story, is learning how to count their sides. So what exactly is a side? Super simple. It's just one of those straight lines that makes up the border of a shape. This is the first piece of information we collect when we're trying to figure out what we're looking at. Okay, pop quiz. Look at the triangle on the left. Counting its sides is a piece of cake. 1, 2, 3. Done. But now look at that hexagon on the right. All of a sudden, it's way easier to lose track, right? You could count a side twice or maybe miss one completely. So how do we make sure that doesn't happen?
Well, this is where a student from our source material, a girl named Eva, has this absolutely brilliant idea. She just says, "This looks tricky. I will mark each side as I count it." It's so simple, but it's genius. It's a perfect example of a great learning trick. You take something that's abstract in your head and you make it physical, something you can see.
And here's her method, step by step. You just pick any side to start, make a little mark on it, count 1. Then you just go around the shape, marking and counting each side. 2, 3, 4, until you get back to the side with your first mark. It's totally foolproof. It turns what could be a confusing mess into a simple, confident process.
So why is a simple method like this so powerful? Well, because it takes a task that could cause a lot of errors and confusion and turns it into this clear, repeatable system. It's actually teaching a core problem-solving skill that goes way beyond just counting the sides of a shape. Okay, so counting sides, check. But that's really only half the story. The next piece of the puzzle, our second big clue, is figuring out where all those sides meet.
And that meeting point is called a vertex. Or if there's more than one, we call them vertices. Don't let the fancy word fool you, though. It's just the mathematical term for a corner. It's simply the point where two sides come together. Now let's bring in another student, Mo. And this is where it gets really cool, because Mo has this aha moment. He realizes he can use the same strategy that worked before for a whole new problem. He says, I can mark the vertices like I did when I counted the sides. And that's just fantastic, isn't it? It shows he's not just memorizing a fact, he's actually building a toolkit for solving problems. And when you put all of this information together, something really interesting starts to happen. A triangle has 3 sides and, 3 vertices. A square, 4 sides, 4 vertices. A pentagon has 5 of each. A hexagon has 6 of each. For all these regular shapes, a super clear pattern just jumps out at you. The number of sides is always the same as the number of vertices. That's a huge clue.
All right, so we've got our tools now. We can count sides, we can count vertices, but so what? What's the point of all this? Well, the real magic happens when we take this knowledge out of the classroom and start using it in the real world to actually describe and understand all the stuff around us. So check out this example from the source, a stop sign on a road in the UAE. Using Eva's method, we can count the sides, 1, 2, 3, all the way around to 8. An 8-sided shape? We have a word for that. It's an octagon. And just like that, we have a precise mathematical way to describe an object we see every day. Or how about this amazing structure, the Dubai frame? We can pretty clearly see it's a giant rectangle. And because we know it's a rectangle, we know it has 4 sides. And because of that pattern we spotted earlier, we also know it has to have how many vertices? That's right, 4 corners. This basic knowledge isn't just for tests, it's everywhere.
Now, this last section is, I think, maybe the most fascinating part of all, because it's not just about getting the right answer, it's about figuring out how well you understand something. And the source material uses this really wonderful metaphor to explain it.
I want you to meet the learning lizard and the confident camel. Now, these aren't just a couple of cute drawings. They actually represent 2 really important stages in any learning journey. The stage where you're still kind of figuring things out, and the stage where you've truly mastered something. So the learning lizard, on one hand, that's the feeling of, I'm still figuring this out. I think I get it, but I definitely need more practice. But the confident camel, on the other hand, embodies, I understand this really well. In fact, I get it so well, I could probably explain it to someone else. And the key here is that it's not about passing or failing. It's about being honest with yourself about where you are in the process.
And that's the whole point, right? The goal of teaching this way isn't just to get kids to say, a triangle has 3 sides. It's to build their confidence and their self-awareness so that they can become a confident camel. And once you have those tools and you have that confident camel mindset, you can look at a worksheet like this one. It's full of weird, irregular, kind of funky-looking shapes. But it's not scary anymore because you have a method. You can mark the sides, you can mark the vertices, and you can systematically figure out even the most complex-looking things.
Because at the end of the day, the world isn't made of perfect little squares and triangles, is it? It's this beautiful, messy collection of complex and irregular shapes. But now, you have the fundamental tools. You know how to look for sides and vertices. So the question I want to leave you with is, now that you have these tools, what shapes are you going to find?